Hello and welcome everyone. This is Mark Henry, and this is another Augmantic Walkabout Wednesday. Today we're going to talk about automating event response using opEvents, event actions. One of Augmantic's primary goals is to help take engineering teams from a reactive standpoint, where you're simply responding to incoming tickets, and move you to more of a proactive standpoint, where you're able to improve the quality of your network experience, reduce the amount of incoming trouble tickets that you have, and of course, improve the overall quality of your user experience. One of Augmantic's primary goals is to help you implement the IT service management maturity model. opEvents addresses this by focusing on level 1, which is the operational process engineering level, and level 2, which is a service delivery process engineering point. opEvents helps improve initiating problem management processes, alerting event management, measuring component availability, setting thresholds, predicting problems, automating response, and increasing or maturing your problem configuration, change asset, and performance management processes. Today we're going to talk specifically about event processing and how events are handled, and then how we respond to them with event actions. opEvents processing flow is straightforward. This same processing flow happens as a background process for each and every event that happens across your network. We start by applying an archive list, determining which events need to be stored. We then apply a blacklist, determining which events should never be acted on, a whitelist, which determines which events should always be responded to. We then correlate events into outages. We deduplicate events. We then determine or change the priority of those events. We conduct any actions that are appropriate for the event that has occurred. And then we start the escalation process for that event. All of opEvents configurations are handled through a series of configuration files, which are located in the omk/conf directory. Today, we're going to talk about the priority, actions, and escalations package, which is contained within the eventactions.nmis file. The eventactions.nmis file determines what types of events and actions will be acted on and what will be done in response to them. For example, opEvents ships with a series of actions specifically for Cisco iOS devices, for Linux devices, and for all other types of events that happen across the network. Let's shift over to opEvents and take a quick look at an event and the actions that were taken for it. This is Asgard. Asgard is a small Cisco 1841 router that's on our demo network. Asgard suffered a node down event. The node down was generated when the device failed to respond to a ping from the NMIS polling server that's managing that device. So we had a ping failure that generated a node down event. In response to that, you'll notice that opEvents adjusted the priority of the event. So the priority of a node down is generally a 7, but based on a rule set that was met in the event actions file, we adjusted that by adding 3 to the priority and making it a priority 10 event. Adjusting your priority this way, of course, events adjust the way that event escalations occur, who gets notified, when they get notified, and also it can adjust what additional actions are taken for that. In addition to adjusting the priority, we also ran a ping against that, and then we ran an MTR. So we ran 2 troubleshooting scripts that most engineers would run when they were told that a specific device had gone node down or non-responsive. Now, these were run automatically in the background, and the results of those troubleshooting scripts were captured and stored with the event. So you'll see at the bottom of the screen, we have the output from the ping node. The ping node ran out. We pinged asgard.augmantic.com. We hit it with 5 different pings. We have 5 packets transmitted, 5 received, 0 packet loss, and a total time of about 4 seconds. The MTR node is listed at the bottom of the screen. You'll see that we ran an MTR on demo from demo.augmantic.com, which happened to be the polling server responsible for the device, out to asgard.augmantic.com. There was 0% loss. The average time was 1.0 seconds. The worst time was 1.3, standard deviation 0.2. It's important to note that event actions don't need to be troubleshooting in nature. anything that can be run from a Linux command line, any Linux command, any bash script, any Perl script, a PHP script, a Python script. If you want to call out to a third-party system, you want to call out to a RESTful API, you want to run commands that way, you want to execute a file remotely, you want to copy files somewhere. Anything that can be done from a Linux command line or in some kind of a Linux-capable programming language can be part of a response done in response to an event that has occurred and been processed by opEvents. So let's take a look at what this file looks like. So this is the event actions.nms file. This is a sample of the one that ships with opEvents 3.2 currently. So you'll see right off the bat, we're doing a check for every event. We're going to do a check, and if the device, if the node model is a Cisco router, and the event, for example, is a proactive CPU, we want to adjust the priority. We want to add 2 to it, and then we want to run a script called iOS CPU router. And I'll show you what the scripts look like in a moment. So we're doing more comparisons. Every parameter that's stored about the device in question is available to you here in Event Actions. This is completely documented on Opmantic's wiki under the opEvents section. So it talks about all of the different types of parameters that are available to you to do comparison. So for example, we're comparing node model and the type of event. Later on in this file, you'll see we're comparing role type. So the role assigned to that device by you when you added it to NMIS. In this case, if the role type is distribution and the event is BGP neighbor, then we're adding, again, 2 to the priority. We're running the script ping node, and we're running the script troubleshoot BGP. Let's take a further look. You don't have to do a direct comparison, in this case equals to distribution. You can do a like comparison. So if role type is like, distribution or core or access, and event is node down, then run a ping node. And there are more examples that ship here. Here's an example where we're looking at the customer. So if node.customer equals pack, or that could very well be if node.customer equals sales team, if node.customer equals Coca-Cola, whatever your customer is, and event.any, and role type is distribution, event is stateful. The point here is that you can use this system to create specific response rules based on the type of customer, the state of the customer, the SLA that you've assigned to the customer, the location, so you can respond differently for different locations, for different customers. Any parameter that you may store in relationship to that device, the services the device offers, where the device is located, etc., is available to you for comparison. So you can create everything from very, very simple rules to extremely granular rules. So you can break it down by VIP customers, customers in the northwestern area of your city who are on the 3rd floor, for all Cisco routers that start with the name Molly. Here's an example where we are responding to a service. So if event.event equals service down, run a ping node. Again, another example of a comparison for a node.customer. Let's go ahead and slide down through this file and take a look at what these scripts look like. So this is the script section of the event actions.nms file. Here you'll see, for example, the script mtr node. Remember now the Cisco router that had the ping loss? We ran an mtr on this. So you'll see that we're calling the actual mtr command from the Linux command line. We're passing to it node.host, and we are specifically saving the output of that script. You'll see there are many other examples that are here. So you'll see there's traceroute is included, a simple ping, and again, we're setting arguments for that as well. Ping neighbor, so you can actually use event.element rather than event node.host. Troubleshooting BGP, we're actually calling out, in this case, if you have opconfig, which is Opmantic's configuration and compliance module, installed, we can actually reach out to opconfig and have opconfig reach out to the device and execute a set of command scripts against that device. Here's an example of top flow talkers. Again, we're using opconfig to execute a set of commands against that. An example of running Linux processes, again using opconfig to gather Linux-based information. We've also done an example here for generating an outbound SNMP trap. So we had a client come to us and ask us if it was possible that when opEvents evaluated certain events, for opEvents to actually generate an SNMP trap and send it to an other application for further evaluation. So we did a proof of concept and we made that available to you here in opEvents as well. We've often had people come to us and ask us, what happens if I'm monitoring a service and the service goes down and it doesn't auto restart? So we actually have a small script sample that now ships in the OMK bin directory called restart service, and you can reach out to that and push back to the system and automatically restart the service in question. Thank you all very much for your time today. That concludes our review of opEvents action response system through the eventactions.nmis file. Again, my name is Mark Henry. I appreciate your time and attention. And if you have any questions at all, or if you'd like to talk to an engineer here at OpMintech about how we can help you automate your event actions and help you move from a reactive to a proactive engineering team, you can give us a call or email us at contact@opmantech.com. Thank you and have a great Wednesday.